Hello, welcome to today's lesson. We're talking about greatest common factors from 5.2 out of our book. This is our first lesson in Unit 4. And like I said, we're talking about greatest common factor. First thing we need to remember is what is a factor? Remember we talked about factors way back in the first unit, I believe. We talked about how factors are the math facts that make up a number. So remember we had like 12, the factors of 12 were 1 and 12, 2 and 6, and 3 and 4. So now today we're going to take that one step further and talk about the greatest common factor. That's when we find the factors of two different numbers, and the biggest one that they have in common is considered the greatest common factor. So let's go ahead and try it out. We've got gardening. We got two different methods we're going to try today, first of all. And the first method is the most basic one. And that's what we're going to start out with. So let's look at our problem here. We're dividing a garden into sections. We have 64 marigolds and 120 petunias. You want each section to have the same number of each type of flower and use all the flowers. At most, how many sections can you have? So that's where we need to find the greatest common factor of 64 and 120. All right, so first let's go ahead and list all of the factors of 64. We know that we have 1 and we have 64. We know that 64 is an even number, so we've got 2, and half of 64 is 32. 6 plus 4 is 10, which is not divisible by 3, so 3 is not going to work. But 4 is, in fact, a factor. Because 32 is even again. So we've got 4 and 16. 5 doesn't work. 6. Does 6 work? Well, no, we have to have 2 and 3 here, so 6 doesn't work. 7, nope. 8 times 8 is 64. Perfect. So we have 1, 2, 4, 8, 16, 32, and 64. So now we need to do the same thing with 120. So we've got 1 and 120. We have 2, it's an even number, so 2 and 60. We can take 3 times this, 3 times 40. We can take 4 times 30. Ooh, it ends in a 0, so we got 5 as well. 5 times, 5 times 20 gets me to 100. 24 it must be. 6, oh my goodness, I'm running out of room here. 6 times 20. 7, no. 8, yes. Oh my goodness, I'm going to have to write this down here. 8 times, let's see, 8 can go into 12 one time. We have 4 left over. 15, 8 times 15. And then we also have 10 times 12. Ooh, that got kind of ugly. Normally I like to see them all in one line, but I ran out of room there. So let's see. Now we just want to circle or highlight the ones that they have, that they share. So they both have a 1. They both have a 2. They both have a 4. I always look at the one that has the fewer ones. They both have an 8. Do they both have a 16? Nope. A 32? Nope. A 64? Nope. So that is all we have for our common factors. All of those are common. They share them. Remember, common means share. And so the greatest common factor, that would mean the biggest one that they have in common, is what? Hopefully you said 8. 8 is what our greatest common factor for these two numbers should be. So method 1 would just be to list all the factors for all the numbers that you're comparing, circle or highlight all of the common ones, and then find the biggest one you have, and that's your GCF, your greatest common factor. Well, as you could see, even with this number here, this one had a lot of factors. That was a lot, and it's easy to miss 1 or 2 of them. So this isn't always the best method because it's easy to goof up. So we're going to try a different one. If you can think back to that first unit, and we talked about factor trees. We're going to deal with some factor trees here. We got the same problem going on. So I'm going to instead go, 64 was the same thing as 8 times 8, right? Both of these are not prime, they're composite, so that means when it's composite, they each get a twig. So what times what equals 8? Well, I know I can do 2 times 4 is 8, and I can do 2 times 4 here. I now have a couple prime numbers. 2's are a prime number, so I'm going to circle them. That means they're dead ends. But the 4 is still composite, so they each need a couple of branches there. 2 times 2 is how we get 4. So now I've got all dead ends. I can circle all of them. So I can go on down here and write my prime factorization for 64 is 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Perfect. So now let's go over here. 120. I'm going to break that down into 12 times 10 to get it small. Neither of those are prime, so I'm going to go again. I got 3 and 4, and I have 2 and 5 here. Oh, 2 and 5 are both prime. 3 is prime. 4 needs twigs. So 4 is found by getting 2 times 2. So now I'm going to go down here and write my prime factorization for 120. And remember, I start with the small numbers, so I got 3 2's, so I have 2 times 2 times 2. And then I've got a 3 and a 5 times 3 times 5. So here's where we need to take it another step. And what we're going to do for method 2 here is to look at these 2 prime factorizations and circle the ones that they have in common. We've got a pair of 2's here, I have a pair of 2's here, and I have a pair of 2's here. And the rest, I've got a 2 and a 3, a 2 and a 5, a 2 and nothing. These are all that I have in common. So I'm going to take whatever, each circle. What do I have circled here? I have a 2 circled here, a 2 is circled here, and 2 is circled here. When I take 2 times 2 times 2, I get 8. That was the same answer we got the first time. That's how we do it this second method as well. So method 2, we use a factor tree to find the prime factorization. So you're going to want to write this down in your notes. Make sure you get this down. Then we list the prime factorizations. That's the expanded form out. We don't want to leave it as 2 to the 6th power. We want to write it as 2 times 2 times 2 times 2 times 2 times 2. And then we circle the common factors. And our last step is to multiply the common prime factors that you get in order to get your GCF. So with that, let's try another one. That gets a little tricky here. So we've got 72 and 108. We can always do method 1, but we said that one kind of, unless they're smaller numbers, it's easy to forget about a factor or 2 and make a mistake. So we're going to be practicing method 2, which is factor trees. So let's go ahead and figure out how would we break 72 down. 72, I know, is the product of 8 times 9, right? Neither one of these are prime numbers, so I've got to add a few more branches here. 8, I can get it by taking 2 times 4. 9 is 3 times 3. The 3's are prime numbers, so those are dead ends. I've got to circle those. 2 and 4. 2 is a prime number. 4 is not, so I've got to add legs. And then 4 I can get by taking 2 times 2. So I'm at all circles here, all dead ends here. So I know that I have 2 times 2 times 2 times 3 times 3 for my prime factorization for 72. Then we're going to go ahead and 108. I'm not sure what the factors of 108 are, but I know it's an even number. So I'm going to take 2 and then figure out what's half of 108. Well, half of 100 is 50. Half of 8 is 4. So 54 would be half of 108. 2 is a prime number, I know. 54 is even. I know that's not. So 54, do I know any math facts that equal 54? Well, I think, if my memory serves me correctly, that 54 is 6 times 9, right? Hopefully you remembered that. 6 times 9, neither one is prime. prime, so I'm going to add legs again. 6 I can get by taking 2 times 3. Both of those are prime, so I'm going to go ahead and circle them. 9 is the product of 3 times 3, so those are prime. I'll circle those. Now I've got all dead ends, so I can write my prime factorization. I have 2 times 2 times 3 times 3 times 3. So I'm on to my step 3. I need to circle anything they have in common. They don't need to necessarily be right on top of each other. These ones are, so I've got a 2 in the top row and a 2 in the bottom row, and I have a second 2. But then I get here, I've got a 2 and a 3, but I have a 3 here, so I can do that. Oh, and look, I have another match. It's kind of like playing that memory game. I've got matches here too. So all together, I have 4 circles. That means I'm going to have 4 numbers down here to multiply together. My first circle is of 2's. My second circle is 2's. My third circle is a 3. My fourth circle is a 3. So now I need to take 2 times 2 times 3 times 3. Well, let's figure it out. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is, dun, 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 36 is the greatest common factor, the GCF of 72 and 108. Good job. So again, here's our key concept. They've just kind of put it in smaller forms if you want to rewrite that again. But we have in your homework, you're going to come across where they're asking the greatest common factor of 3 different numbers. And I need you to know that we can do that too. We're going to do the same thing. We've got 16. When we break that down, we've got 4 and 4, which turns into 2 and 2. Then we've got 24, which we can break down. I should have circled these. I didn't circle all of those prime numbers here. Then we've got 24, which is, let's do 6 times 4. Neither one of those are prime, so I've got to go 2 times 3 here, which are both prime, and 2 times 2, which again are both prime. And then I have 36 as my last one. 36 is 6 times 6, which both are composite, so I've got to go 2 and 3, and 2 and 3 for both of those. So when I do this, now I'm going to line up all 3 of them together. I've got 16 was 2 times 2 times 2 times 2, right? 24 was 2 times 2 times 2 times 3. And 36 was 2 times 2 times 3 times 3. All right, so now we've got to circle what we have in common. We have all 3 rows have a 2. All 3 rows have another 2. Ooh. We've got a 2 and a 2, but oh, not a 2 there. A 3 and a 3 here, but not a 3 there. So this is all I have. I only have 2 circles, which means I'm going to do 2 times 2 for my greatest common factor of 4. That's the closest thing I have, or the greatest common factor between those 3 numbers. So the greatest common factor of 16, 24, and 36 is 4. I got one last one I want you to try on your own. So I want you to go ahead and do that second method, make the factor trees for 48 and 54, then write your prime factorizations out, circle what they have in common, and multiply what you have circled to find out what the greatest common factor, that's what you're looking for, is the GCF, the greatest common factor of 48 and 54. We'll see you in class tomorrow. Have a great night.